first part of the trig identity. And this knowledge is very important for physics students. For the math students, we have more to do. So I will discuss those in my other sections. So first of all, we will try to understand how to get the initial identities. Consider a right angle triangle and say this is ABC, the points. So suppose the angle between AB and AC is theta. So you can use the Pythagoras theorem. So if you use the Pythagoras theorem, what do you get here? So hypotenuse would be AC squared is equal to AB squared plus BC squared. Now, suppose now we will use sine cos tan relations here. So sine theta, you can say that would be opposite divided by the hypotenuse. So it's going to be CB divided by AC. And then we can have cosine theta. So the cosine theta would be AB adjacent divided by the hypotenuse, AC. And the tan theta would be opposite, which is CB divided by AB. Now what I will do, from equation number, suppose this is A, equation A, B, and C. So from equation B, I can subject AB, which is AC cosine theta, and obviously AB squared would be AC squared cos squared theta. Now from equation C, we can get CB. CB would be actually not equation C, equation A. So from equation A, we get CB, which is AC sine theta, AC sine theta, and CB squared would be then AC squared sine squared theta. So this would be my dth and eth equation. Now, equation number 1 is my original equation. So from 1 DE equations, from 1 D and E equations, we can have a substitution, which is AC squared is equal to AB squared. Now AB squared is equal to AC squared cos squared theta, plus, and BC, CB the same, so it's going to be AC squared sin squared theta. So now from here you can see AC squared is common, so you can cut those three together. So 1 is equal to cos squared theta plus sin squared theta. And this is very important for physics students and obviously for the math student, but for physics, these three identities which I'm going to show you is very important. So now this is my main equation, capital A. Now what I will do, I'm going to take capital A equation and divide the whole equation by sin squared theta. So when you divide that by sin squared theta, what you get? So 1 divided by sin squared theta is equal to, here you get cos squared theta divided by sin squared theta, plus you get sin squared theta divided by sin squared theta. Then you get 1 divided by sin squared theta is cosec squared theta, and then cos divided by sin is cot, and that would be cot squared theta, and sin squared divided by sin squared is equal to 1. So this is my other equation, bth equation, capital Bth equation. So note, we have to know that 1 divided by sin theta in trigonometry is denoted by cosec theta, and 1 divided by cos theta we denoted by sec theta, and then 1 divided by tan theta is cot theta, and tan theta is equal to sin theta divided by cos theta, and cot theta is nothing but cos theta divided by sine theta. So these are the things that we should know in here. Now again, we will get equation A, and we will divide it by cos theta. So when you do that, you get 1 divided by cos square theta is equal to cos square theta divided by cos square theta plus sine square theta divided by cos square theta. So now you can see 1 divided by cos square theta is nothing but sec square theta, and here you get 1 plus sine square divided by cos square theta is going to be tan square theta. Why? Because sine theta divided by cos theta is tan theta. So this is my third and sixth equation. So these are the three important equations that we should know clearly. So I will summarize it. The first equation would be 1 is equal to sine square theta plus cos square theta, and the other one would be sec square theta is equal to 1 plus tan square theta. The next one would be cosec square theta is equal to 1 plus cot square theta. So